Bismillahirrahmanirrahim. Dear students, this is our lecture number 30 regarding the reaction dynamics, and we are now discussing the reaction institutions. Now, today we will discuss the chain reactions. Contents: chain reactions, general treatment of chain reactions, the basic experimental methods of kinetics, kinetic study of slow reactions, monitoring of first order kinetics by spectroscopy, kinetics of fast reactions, methods of kinetic study. Similarly, we will also discuss the uh, reaction mechanism and some examples of reaction mechanism in this chapter. Now, dear students, chain reactions. A chain reaction may be defined as reaction in which active intermediate species are produced in a series of successive elementary processes which carry on the reaction at a rapid rate for a longer period of time till the final products are obtained. That is, a chain reaction may be defined as a reaction in which active intermediate species are produced in a series of successive elementary processes which carry on the reaction at a rapid rate for a longer period of time till final products are obtained. Such types of reactions were first studied in 1934 by Frank O'Rice and Carl F. Hertzfeld, and hence these reactions are referred to as Rice-Hertzfeld reactions. Now, dear students, the chain reaction proceed in the following steps. Step number 1, chain initiation. These steps involve a slow generation of highly reactive intermediate species called carriers. The chain initiation may take place thermally or photochemically. And that is step number 1 is the chain initiation. These steps involve a slow generation of highly reactive intermediate species called carriers. The chain initiation may take place thermally or photochemically. Step number 2, chain propagation. The carriers, being transient, react with other reactant species at faster rate to carry on the reaction and give rise to intermediate steps leading to the formation of final products. Such steps are known as chain propagation steps. That is, the chain propagation. Step number 2, the carriers being transient react with other reactant species at faster rate to carry on the reaction and give rise to the intermediate steps leading to the formation of the final product. Now the carriers, they are short-lived. They react with the other reactant species in very faster rate and gives rise to intermediate steps leading to the formation of the final products. Such steps are known as chain propagation steps. Step number 3, chain transfer. Chain transfer. In case of some propagation steps, the initial chain carriers are consumed along with generation of new chain carriers by the reaction of farmers with the existing reactant species. Such steps are called chain transfer steps. Step number 3, that is the chain transfer. In case of some propagation steps, the initial chain carriers are consumed along with the generation of new chain carriers by the reaction of farmers with existing reactant species. Such steps are called chain transfer steps. That is, uh, the chain reaction proceed in the following steps. Step number 1, chain initiation. These steps involve a slow generation of highly reactive intermediate species called carriers. The chain initiation may take place thermally or photochemically. Step number 2, chain propagation. The carriers, being transient, react with other reactant species at faster rate to carry on the reaction and give rise to intermediate steps leading to the formation of the final product. Such steps are known as chain propagation steps. Step number 3, chain transfer. In case of some propagation steps, the initial chain carriers are consumed along with the generation of new chain carriers by the reaction of farmers with the existing reacting species. Such steps are called chain transfer steps. Step number 4, chain inhibition. Step number 4, that is chain inhibition. This step involves removal of the product with simultaneous regeneration of more active species with a net decreasing effect on the rate of overall reaction. That is chain inhibition. This step involves removing of the products with simultaneous regeneration of more active species with a net decreasing effect on the rate of overall reactions. Step number 5, chain termination. Step number 5, chain termination. This step involves removal or destruction of active intermediate species, that is carriers, in such a way that these are no longer available for further chain initiation or propagation. This step comes into action only when there is no more reactant to be converted into product. That is step number 5, chain termination. This step involves removal or destruction of active intermediate species or carriers in such a way that these are no longer available for further chain initiation or propagation. This step comes into action only when there is no more reactant to be converted into product. Dear children, there are 5 uh, steps involved in the chain reaction. First is the chain initiation, second is the propagation, third is the chain transfer, fourth is chain inhibition, and fifth is chain termination. Characteristics of chain reactions. Now, dear children, all the chain reactions have the following characteristics. Number one, every chain reaction involves slow generation of active intermediate species at the beginning, followed by fast propagation steps. Number two, the rate of reaction is much higher than expected from Boolean theory. Number three, the mechanism is complex. Number four, in case of chain reaction, the rate is zero at the beginning and rises to maximum and finally decreases with time. That is, in case of chain reaction, rate is zero at the beginning, then rises to maximum and finally decreases with the time. Number 5, in case of photochemical reactions, very high quantum yield is observed. The chain reaction usually show fraction order. That is, the order of reaction in case of chain reaction is in fractions 1 by 2, 1 by 4, etc. The chain next is the chain reactions have induction period. There is a time gap in between the starting of the reaction and up to which the rate is experimentally observed. This time lag is called induction period. Again, characteristics of chain reactions. All the chain reactions have the following characteristics. Every chain reaction involves slow generation of active intermediate species at the beginning, followed by a fast propagation step. Number 2, the rate of reaction is much higher than expected from Boolean theory. Number 3, the mechanism is complex. In case of chain reaction, the rate is zero at the beginning, then rises to maximum and finally decreases with time. Next is, in case of photochemical reactions, very high quantum yield is observed. The chain reaction usually shows fraction orders. The chain reactions have induction period, that is, there is a time gap in between the starting of the reaction and up to which The rate is experimentally observed. This time lag is called induction period. Next is the steady state. Now in chain reaction, we use the steady state hypothesis. According to this hypothesis, the concentration of reactive intermediates remains constant during the course of chain reaction. That is, according to this hypothesis, the concentration of reactive intermediate or carriers remains constant during the course of a chain reaction. If Ri is the reactive intermediates or carrier, then concentration of Ri is equal to constant, or you can say dri over dt, dri over dt, that is equal to 0. Now what is steady state? Again, according to this hypothesis, the concentration of reactive intermediates remains constant during the course of a chain reaction. If Ri is the reactive intermediates or carriers, then Ri concentration is constant, or we can say dri over dt, that is equal to 0. That is change in concentration of intermediate is 0. Chain length. The chain length may be defined as the number of cycles that a radical or an atom can take part in between the initiation step and termination step in chain reaction. That is, chain length is equal to rate of disappearance of reactants over rate of chain initiation. When the chain length may be defined as the number of cycles that a radical or an atom can take part in between the initiation step and the termination step in chain reaction. That is, chain length is equal to rate of disappearance of reactants over rate of chain initiation. Now from the above expression, it is clear that the reactions with slow termination steps have long chain length, and these reactions are very fast in giving rise to product of the reactions. Now, dear students, again, according to this hypothesis, the concentration of reactive intermediates remains constant during the course of a chain reaction. If Ri is the reactive intermediates, then concentration of Ri, that is equal to constant, or you can write dri over dt, that is equal to 0. That is change in concentration of reactive intermediate is 0. Chain length. The chain length may be defined as the number of cycles that a radical or an atom can take part in between the initiation step and the termination step in chain reaction. That is, chain length is equal to rate of disappearance of reactants over rate of chain initiation. From the above expression, It is clear that the reactions with slow termination steps have long chain length, and these reactions are very fast in giving rise to the products of the reaction. Dear students, we can explain this with the help of an example. Uh, uh, the halogenation. Halogenation is substitution reaction in which hydrogen atom of an alkane is replaced by a halogen atom, maybe fluorine, chlorine, bromine, or iodine, is called halogenation. Uh, Fluorine reacts too vigorously and iodine does not react. So the halogenation would mean usually the chlorination and bromination of alkane. It takes place under the influence of heat or light. Thus, chlorine reacts with methane in the presence of sunlight to produce HCl and methyl chloride. Uh, we can represent by the equation, that is CH4 plus Cl2 in presence of sunlight Hnu, that is equal to that will convert it into CH3Cl plus HCl. As the concentration of CH3Cl builds up, it can itself undergo further substitution to form HCl and methylene chloride CH2Cl2. CH3Cl plus Cl2 in presence of sunlight C2 CH2Cl2 plus HCl produces. In a similar way, chlorination can continue to yield chloroform CHCl3 and carbon tetrachloride CCl4. For example, CH2Cl2 plus Cl2 in presence of sunlight, it will produce CHCl3 plus HCl chloroform plus HCl. The chloroform produced then reacts with further chlorine in presence of sunlight. CCl4 plus HCl are produced. Dear students, chlorination of methane is a photochemical chain reaction involving free radical mechanism. This means that large amount of products are formed after the chlorine molecule absorbs light to produce a small amount of free radical chlorine. The complete mechanism involves the following three steps. Step number 1, initiation. In the initiation step, chlorine free radical are formed. That is, chlorine molecule will absorb sunlight and will be decomposed into chlorine free radical. This happens when when the quantum of light is absorbed by chlorine molecule and cleaves CCl bond to give two chlorine free radicals. That is, Cl2, it absorbs a quantum of light HNU to produce two Cl dot free radicals. Students, step number 2, that is the propagation step. There are two propagation steps. In the first one, free radical chlorine is consumed and a new free radical CH3 is formed. This happens when chlorine radical attacks CH4 and absorbs a hydrogen from forming HCl. CH4 plus chlorine radical, it will give you CH3 free radical plus HCl. In the second propagation step, CH3 radical attacks chlorine molecule forming CH3Cl and regenerating chlorine radical. That is CH3Cl2 will react with Cl2. It will give you CH3Cl plus chlorine radical again. Thus, in the two propagation steps, the free radical chlorine is being consumed and, regenerated again and again until the chain reaction terminates. That is step number 2 is the propagation step. There are two propagation steps. In the first one, free radical chlorine is consumed and a new free radical CH3 dot is formed. This happens when chlorine radical attacks CH4 and absorbs a hydrogen forming HCl. We can write the equation, that is CH4 plus chlorine radical. It will give you CH3 radical, methyl radical plus HCl. In the second propagation step, CH3 uh, radical attacks chlorine molecule forming CH3Cl plus regenerating chlorine radical. That is CH3 radical that will react with chlorine molecule and will produce CH3Cl plus Cl chlorine radical, free radical. Thus, in the two propagation steps, the free radical chlorine is being consumed and regenerated again and again until the chain reaction terminates. Step number 3, that is the termination step. Dear students, in the termination step, the free radicals are annihilated and thus the propagation of each reaction stops. That is CH3 free radical, this will combine with chlorine free radical forming CH3Cl. CH3 free radical, it will combine with other CH3 free radical forming CH3 ethane. Similarly, chlorine radical plus chlorine radical other, this will combine to form the chlorine molecule again. That is, in the termination step, the free radicals are annihilated and thus the propagation of chain reaction stops. That is, CH3 radical plus chlorine radical, they will combine to form CH3Cl two CH3 methyl free radical, that is CH3 plus CH3 free radical, they will combine with each other forming ethane CH3 CH3. Similarly, two chlorine radicals Cl star plus Cl star, they will combine to form chlorine molecule. The chlorination of methane does not stop at the formation of mono uh, chain methane, but continues as mentioned above and a series of mixture give rise to a mixture of di, tri, and tetrachloromethanes, from which CH3Cl can be obtained by fractional distillation. Chlorination of methane is therefore not a useful laboratory reaction for the preparation of methyl chloride. The quantity of methyl chloride can, however, be increased by using excess of methane.